For this example, we're going to plot the polar coordinate 5, 2 pi over 3, and then find other polar coordinates that have the same position as this one, but have these criteria. They meet these criteria. So first, let's plot the point 5, 2 pi over 3. So if we were to put this in a coordinate plane, 2 pi over 3, that's going to be an angle in the second quadrant. So our initial side, which is called the polar axis, is the positive x-axis here. And then our terminal side is here in quadrant 2, somewhere around here. So this angle here is positive 2 pi over 3. And then the r value, so remember it's r comma theta. The r value is 5, so that means that from here we're going to extend out 5 units on the polar axis. So 1, 2, 3, 4, 5. So this point here in blue is the point 5, 2 pi over 3. So this is our initial point that we had to plot, and we want to find another name for this point, essentially, where the r value is positive. So it's going to have the same distance, r value being positive, but our angle measure is going to be between negative 2 pi and 0. So it's going to be a negative angle measure. So basically what we're trying to do is find an angle that has this same position. Since r is positive, that means that we're going to have positive 5, because this distance is going to be 5 no matter what. We basically just have to figure out what theta is. Now, because this is positive, that means we're going to extend in the direction of our terminal side rather than going in the opposite direction. So if we're extending in this direction, that means that when we draw our angle, our terminal side must end where our terminal side currently is. So we're going to basically just use the negative angle here in this direction. So this negative angle here in green is going to be the negative angle that we want. Now we know that if I add 2 pi over 3 to the absolute value of this negative angle, it should make a full circle. So what angle would complete a full rotation? Well, that's going to be 4 pi over 3. But then we're going in the negative direction. So this is negative 4 pi over 3. So this is our first value that has the same position, but a different looking point. So it's 5, negative 4 pi over 3. So for the next one, we have an r value that's negative, So we're going to have negative 5 and then get some angle measure. Now, because our r value is negative, that means that the terminal side is going to have to be on the side when we extend our angle in the opposite direction, because we're moving in the, so if our terminal side was here, being that r is negative, we're going to have to cross the pole and go to the other side and end up here. Remember, we always want to end up in this position. So we have to, for this angle measure, we have to end on this side over here of our angle. So we're going to be somewhere over here. So we need to know what is, let me get rid of some of this stuff. Just clean it up a little bit. Whoops, that's not what I wanted. Clean this up. We want to figure out what is this angle here. So this angle measure here. Well, to get to this angle measure here, we know that we're just taking 2 pi over 3 and adding half of a rotation, right? Because this forms a straight angle, so we're just adding pi to this. So 2 pi over 3 plus pi is going to be the measure of this angle, which this is just 3 pi over 3. So that's going to be 5 pi over 3. 5 pi over 3. Now, if you see, if I were to draw to 5 pi over 3, if r was positive, that would mean I would extend on this side of my terminal side. But because r is negative, I go to 5 pi over 3 and I go backwards 5 units, and that's going to put me in this same position here. So let's take a look at our last one. Whoops, our last one. Whoops, no. 5 pi over 3. So for this last one, it says r is positive. So again, it's going to be positive 5. But this time, we want our angle measure to be between 2 pi and 4 pi. So in order to do that, we basically need to add a full rotation to whatever this angle measure is here, because 2 pi and 4 pi, that's going to be in the second rotation around the unit circle. So we already have our angle measure 2 pi over 3, but we want to add one more full rotation and end up on this side. Now again, the reason we want to end up on this side is because our r value is positive. So that means when we extend out on our terminal side, we're going to be going in the direction of the terminal side rather than in its opposite direction. So what is this angle plus 2 pi? So 2 pi over 3 plus 2 pi. Well, 2 pi is just 6 pi over 3. So if we can make this 6 pi over 3, that's going to give us 8 pi over 3. So it's 5, 8 pi over 3. And all of these angles here put us in the exact same position as our first one that we plot. They just have a little bit different names. So this shows that polar coordinates are not unique like rectangular coordinates are. It all depends on whether r is positive or negative and whether our angle measure is moving in the positive or negative direction. So we have multiple ways to get to the same position using polar coordinates.